Hey guys, Mr. Milton here. Today we're going to talk about properties of parallel lines notes. Hey guys, Mr. Milton here. Today we're going to take notes of properties of parallel lines. At the end of this video, you should be able to identify the three types of angle pairs formed by a transversal, and you should be able to use angle properties of parallel lines to find missing angle measures. Okay, so we're going to start with a word that we kind of already said, but a transversal is a line that intersects two or more coplanar lines. So as we look at this diagram here, we see line T, we see line L, we see line M. We see that they make 8 angles off their intersection in this case. Okay, well, between those lines, line T is the transversal. Okay, line T is transversal because it intersects line L and line M. Okay, there are 3 types of angle pairs formed by the transversal that we'll focus on. And those angles are alternate interior angles. In the above diagram, which angles are considered interior? So if you think about the transversal T going through L and M, okay, when we look at the interior of L and M, you might think, okay, inside those 2 lines, right? And so interior inside the 2 lines would be these angles. Okay, so we would say 1, 2, 3, and 4. I should really put angles in front of them. Okay. And now when he says which angles are considered alternate interior, now these are pairs. These are pairs of angles that would be alternate interior with each other. And so as we look at that, well, we say, okay, number 1 is interior, and alternate interior, that would be angle 2. See how it's like interior, but now it's on the other side. Okay, other side, touching the other line. Okay, when we look at 4, we see that, and we're like here, its alternate interior angle will be angle 3. Okay, so angle 1 and angle 2 would be considered alternate interior angles, and then angle 3 and angle 4 would also be considered alternate interior angles. Notice how these angle pairs are on alternate sides of the transversal. Okay. Next thing asks us about same side interior angles. So we've already we've already identified the interior. What interior meant? I'm gonna keep that line there. Okay. So which angles are considered same side interior? Well, they're the ones that are going to be on the same side. So angle 1 and angle 4 are on the same side. They are same side interior angles. Okay. And on the opposite side, but still the same side to each other, angle 2 and angle 3. Okay, notice how these angle pairs are on the same side of the transversal. Okay, corresponding angles. Back up so we can still see the diagram here. So which angles are considered corresponding to angle 1 and angle 2? Erase here so I can okay. So angle 1 is corresponding with angle 7. Angle 2 is corresponding with angle 6. Okay, hopefully catch the pattern before we're done. Angle 3 is corresponding with angle 8. And angle 4 is corresponding with angle 5. Okay, you'll notice how all these corresponding angles, all these angle pairs, is made by the transversal and the other. Okay, so yeah, the other line. So you notice how on all of these angle pairs, one of the angles is made by the transversal in L, and the other is made by the transversal in M. Okay, and I like to think of them as like being in the same position on the other line. 1 is bottom left of L, 7 is bottom left of M, 2 is top right of M, 6 is top right of L. Okay, those are corresponding angles. Okay, so down here they're just asking us to basically find these and label them of angle pair if possible. So we see angle 1 and angle 3. This line we identify as the transversal. Angle 1 and angle 3 then would be same side interior angles. Angle 5 and angle 6 is top left, corresponding angles. Angle 1 and angle 5. Okay, these are vertical angles. Now we didn't talk about these today, but they're still vertical angles. Angle 3 and 4, they're inside on opposite sides of the transversal. So these are alternate interior angles. And then angle 1 and angle 4, they're both inside, but they're not alternate interior and they're not same side interior. So this is a linear pair. Again, something we talked about at the end of the last chapter, but we still got to make sure we hold on to these. Both of these were talked about last chapter. Very important still. Okay. All right, it says when a transversal intersects two parallel lines, special relationships between the angles occur. So here we're going to talk about these special relationships that happen only when a transversal intersects two parallel lines. So the corresponding angles postulate says if a transversal intersects two parallel lines, then corresponding angles are congruent. Okay, remember we use that a lot for that. Okay, so with that postulate, since L is parallel to M, we can conclude that our corresponding angles, angle 1 and angle 2, are congruent. Angle 1 is congruent to angle 2. The alternate interior angle theorem says if a transversal intersects two parallel lines, then the alternate interior angles are congruent. Okay. And so we're kind of given a proof that they want us to walk through. A is parallel to B, and that is given, and you'll notice in the last diagram we were given that L is parallel to M. That's given by these arrows. These arrows indicate that they're parallel. So that's just given information. We didn't have to prove it, work for it. Just had to notice that they did that. From there, they say, okay, angle 1 is congruent to angle 4. Why do we know that? Well, if we look at them, these are corresponding angles. And we already know that corresponding angles postulate tells us that corresponding angles are congruent if the transversal intersects parallel lines. Then it says angle 3 is congruent to angle 4. How do we know that? That's the vertical angles postulate. That's not really a postulate, that's a theorem. Okay, that's the vertical angles theorem. We talked about that last chapter. Remember I said it's going to be important to know that, and there we have it. And so from there it says angle 1 is congruent to angle 3. And we said 1 is congruent to 4, 3 is congruent to 4. So basically since 1 and 3 are congruent to 4, that is a transitive property, not substitution. I guess it could be both, but I like a transitive property way better than substitution for that. Okay. So by the transitive property, then we can prove that the alternate interior angles are congruent. Okay, so this is our proof in general that alternate interior angles have to be congruent. Now, really quick, I just want to point out the difference between these two and why we did this differently here. postulate, theorem. Okay, remember, a postulate or an axiom is an accepted fact. A theorem is a proven statement. Okay, for the corresponding angles, we accept this because there's not really necessarily a proof we can walk through for it, but we found it to be true and we accept it. Using this accepted fact, we can prove alternate interior angles theorem. Okay, and probably same side interior angles theorem. Let's see. Same side interior angles theorem says if the transversal intersects two parallel lines, then same side interior angles are, switching it up on you, supplementary. Remember, that means adds up to 180. So here, again, we're given that A is parallel to B by those arrows on our lines. Then we have 1 is congruent to 3, and that is because these are corresponding angles. That's the corresponding angles postulate. Okay. From there, we have angle 3 plus angle 2 is 180. Angle 3 plus angle 2 is 180. We know that because that's a linear pair. Remember from last chapter, told you that was going to come into play. It's a linear pair. 3 plus 2 make a line. 2 angles make a line. Linear pair. Okay. And angle 1 plus angle 2 equals 180. And this is substitution. Substitution, because we're just substituting something that we said was equal to each other already, right? We said 1 is equal to 3. Here we use 3. Here we said, hey, let's substitute 1 in for 3. Okay, so in both of these cases, we use the corresponding angles postulate, an accepted fact, to prove the same side interior angles theorem and the alternate interior angles theorem. Remember, that only works when our lines are parallel. Okay, again, notice how the first property is a postulate while the other two are theorems. The difference is that the theorem is able to be proven, while the postulate isn't. It's just an accepted fact. Okay, so let's look at some examples here. Find the values of the variables. Love these pictures because it makes it feel like, wait a second, this is way different than you just talked about. Okay, so here's my big hint for this. Whenever I see my parallel lines, I'm going to extend them. No, I know I'm running into that space, but I'm going to extend them so it looks like the things that I just talked about. Here's my transversal, extending that. Okay, great. All right. So here I have these. And I'm going to use my angle pairs to find out what I should do. Okay. As I start this problem, I'm looking at X, and I see it's on the top left of the transversal, and this line intersects. And for 70, it's the top left of this transversal line that intersects. Okay, so those are corresponding angles. And I know that corresponding angles are going to be congruent. So X must be 70 degrees. Now there are a couple of ways that we can find Y, but I'm going to use same side interior angles to find it here. Because as I look at this picture, change my colors, I know that these two angles are same side interior angles. They're inside the two lines the transversal meets, and they're on the same side of the transversal. I know that same side interior angles should add up to 180 degrees. So 50 plus Y plus 70 equals 180. Notice that I did not cut it off at this line. This line being here was more of a distractor than anything that helped us out. Right, so it didn't really pay attention that this whole angle is inside and this whole angle is inside. Okay, so 50 plus Y is that whole angle. So we got 120 plus Y equals 180. Subtract 120, Y equals 60. Okay, you'll notice here, as I erase this, that we're given that these lines are parallel. Number 2, we have 15x plus 7 and 18x minus 4. seems to be here and here. That's what I would think. Okay, you really want to jump into this problem, but you cannot. And here's why. If you could, you would say, hey, these are alternate interior angles. Let's set them equal to each other, which, yeah, they are alternate interior angles. But we have to remember this really important part of this section that gets overlooked so many times. Alternate interior angles are congruent when a transversal intersects two parallel lines. In this diagram, you'll notice that they give us two lines that appear to be parallel, but they don't tell us. Okay, and so we cannot solve this as it is. Not enough information. The info. Okay. Because they need to tell us that these are parallel in order for us to solve them. Okay. So, no, that's the last question there, but very important for us to realize that we can only set those equal to each other like that when we're given the information that those lines are parallel, because that's the only time, again, read this top thing. That's the only time that these special cases, corresponding angles being congruent, alternate interior angles being congruent, and same side interior angles being supplementary, only time those three cases are true. Okay. All right. See ya.